Hello everyone, myself Puja Waykole and we are a group of 5 girls and today we are so excited to explain our project with all of you whose topic is apple quality prediction and it is totally based on machine learning. So let's begin with the introduction. So as we already know that normally we check the quality of the apple with our hands and also this process is slow, not so fair and also inaccurate sometimes. So we have built such a machine learning model which predicts the quality of the apple whether it is of good quality or bad quality, and this process is actually automatic, fast and also so accurate. So I will show you the quick overview of the dataset we have used. So we have taken this apple quality.csv file from the official website of Mythos Philologies, and it contains total 8 features and one target variable. So all these features are of numerical type. So first is AID. This is just used as an identifier. Then next is size, that shows the size of the apple. Then other is weight, which shows how heavy the apple is. Then other is sweetness, that shows the sugar content the apple is having. Then crunchiness means how the apple feels crunchy when it is beaten. Then juiciness, that is the sugar content in that apple. And then ripeness, which shows the apple is whether it is less ripe, overripe and all. Then acidity, which shows how sour the apple tastes. And we have one target variable which is of categorical type, so it contains two categories, good and bad. So now let's focus on our actual project which we have implemented in Jupyter Notebook.
First of all, we import all necessary libraries that are required to our project. Then we import the warnings to ignore the warnings. Then we load the dataset applequality.csv file from the Mythos official website. Then we print the first 10 rows to see how data look like. Then we do the exploratory data analysis to clean the data. Then df.shape prints how many rows and the columns our data has. df.columns shows the names of all the columns. df.info give details about the each column like type and if any values are missing. Shows the df.describe shows stats like average, max, mean for numbers in the data. df.dtype shows the data types of the each column. df.is null and the sum method check the null values are present or not. There are no null values are present. We use strip method to removing any leading and trailing white spaces from all columns if present. Then we check the duplicated values are present in dataset or not. Here we have no duplicates in our dataset. Then we check the target variable quality distribution using unique method. We see we here only two classes are present in quality, good and bad. Then we check values in each class using value counts. Then we plotted the bar chart to see imbalance of the quality variable. Then here we can see there is no imbalance in our quality variable, and also draw a pie chart to the for the same.
Okay. This is the part of the univariate analysis. We will use histogram box plot and density plots to study each numerical feature. Then next, here the core select only the input feature like size, weight, sweetness, etc. AID is a drop because it's just an ID, not useful, and quality is also drop because it is the target variable. Then next, this function is created to visualize one feature at a time using the three plots, histogram, box plot and density plots. Then next, this loop applies the function above to every feature, so it generates the three plot for each variable. This is where you see the all graphs in the notebooks. Then next, this is a simple calculates minimum value of the features, maximum value of the features and a range. Then next, this is just a note. It explains why we calculate variance and standard deviation. Then next, we calculate the standard deviation and variance. So next, this cell detects and remove outlier using the IQR method. First, it prints how many outlier exist in features. Then it removes them from the dataset, and finally, it prints how many outliers remains. Then next cell, after removing outliers, the code reader the box plots for all features. Now the distribution looks cleaner and more reliable for modeling. Then next, this starts the bivariate analysis section where we study how each feature is related to the target variable. Okay, this This is just a note to explain the purpose, compare each features between the good versus bad apples. Okay. These plots, box plot and volume plots for each features comparing goods versus bad apples. Next, compute the correlation matrix for a numerical feature. Then next, plot the correlation matrix as a heat map, and dark red and blue colors show the strong positive negative correlation.
So now our next step is pre-processing the data. This is very important stage because raw data cannot be directly used for training machine learning models. Firstly, we dropped AID column from here because it does not provide any useful information for prediction. Next, we perform target variable encoding. Our target column had text values such as good and bad. We convert it into good into 1 and bad into 0. Then we separated the data into the input and output variables. The input variable are denoted as x and output or target variable is denoted as y, which is quality column. After that, we perform feature scaling. This step is done to equalize the importance of all features while building the model. We can use either min max scalar or standard scalar, but here we used standard scalar to scale our data. Once the data was scaled, we passed it for uh, training machine learning model, training and testing. The training data is used to train the model, and testing data is used to check its accuracy. In our data set, there are 4,000 entries. Out of these, 2,839 entries are used as a training data, and 947 entries were used as training testing data. So that data is well now scaled, properly splitted, and ready for model training. After this, we applied different algorithms to check which performs best. Here, these models are logistic regression, k nearest neighbors, support vector machine, and decision tree classifier, and random forest classifier.
Then we create empty dictionary to store accuracy. So first model we have used to logistic regression. In this we have trained the model using fit function. Then we predict our model, and then you can see confusion matrix. Here are 222 misclassifications. We also plotted to we also plotted ROC curves, and then we uh, found accuracy 0.76% and other like precisions, recall F1 scores and ROC scores and confusion matrix, and this is overall classification report of using logistic regression. Then we use KNN with same steps, and got the accuracy 0.90%. Then our third model is SVM, and the accuracy is 0.89%. Then fourth model is decision tree classifier, and our accuracy is 0.80%. Then fifth model, random forest classifier, and our accuracy is 89%. So after the evaluation of all our 5 models, we have created an empty data frame. In that we have combined the accuracy, precision, recall, F1 score and ROC AUC score for each our model. So yes, after that we have got the chart of the overall performance. So by seeing this, we can say that KNN has the highest accuracy, and at final we decided to use the KNN model for our prediction of quality of apple. Then we also plotted a bar chart for the same. So this is how it looks. So yes, KNN has the better performance than other 4 models. And after this all, we have done serializing, like saving the model. Our trained model is saved, and also the scalar which was used for training that model is also saved with the help of job and yes, we have also developed the GUI application with the help of tkinter. So yes, first of all, we have loaded the scalar as well as model, a trained model with the help of joblib. Then we stored the feature which was required for user input in a list. Then yes, we perform mapping for better understandable output, so that if the model predicts 0, it will show that the apple is of bad quality, and if it predicts one, it will show good apple. And yes, we have designed it with the help of background color, foreground color, and font, and also the size. Then we here user can enter the values of its own choice for each feature. And then we also designed a predict function, and then we built a predict button. For that we specify parameters like text, what will it show, and then background color, foreground color, font, its size, as well as we have used the command that is predict. And then we have ended our application. So the window we got after running this cell is this. Here I have entered the random values. Here I have entered the random values. You can enter any value for prediction. Then when we click this predict button, this is showing me that prediction is of bad apple. So yes, and we have also developed an app, deployed an app on Streamlit. So I will show you. I will also show you that. So this is that app. This is how it looks. So here I have also entered random values. You can enter any value of your choice. And when we click the predict quality, it is showing me that the apple is of good quality. So yes, this is how we have completed our project. Thank you.